Hello, and welcome to this video on converting from moles to grams. In this video, we will guide you through solving the stoichiometric problem of going from moles to grams. By the end of the video, you will be solving problems like this. What is the mass in grams of 0.950 moles of nitrogen dioxide? There are two ways to solve this, and this video will show you both ways. Let's start our look into moles to grams with a less complex problem than the one seen previously. Our first problem to solve is, what is the mass in grams of 5.60 moles of sodium? In this problem, we are looking at grams and moles. The first thing we need to do is ask ourselves what is the molar mass of sodium? Before we find this, let's review what molar mass, you may also hear this called molecular weight as well, is. Molar mass tells us how much 1 mole of an element or compound, in our case it is how much 1 mole of sodium, weighs in grams. To get this, we go to the periodic table of elements. We look up sodium and we use the number below the sodium symbol. In this case, that is 22.990 grams per mole, and this tells us that the molar mass of sodium is 22.990 grams per mole, or that 1 mole of sodium weighs 22.990 grams. Let's first solve this problem just by thinking through. What do we know from the molar mass? We know that 1 mole of sodium weighs 22.990 grams. If 1 mole is 22.990 grams, then with 2 moles, we would double that number and get 45.980 grams. 3 moles, we would add 22.990 grams 3 times to itself, or just multiply 22.990 grams by 3. In our problem, we have 5.60 moles, so we will multiply our weight for 1 mole of sodium, which is 22.990 grams, by 5.60. Upon doing this, we get 128.744 grams. When doing the final answer, your instructor may ask you to round this using significant figures. If that is asked, the answer would be 129 grams of sodium. To sum this up, when going from moles to grams, I will multiply the molar mass by the number of moles I have. Now let's do this using the conversion method. When doing the conversion method, first ask yourself, what do I know? I know that I have 5.60 moles of sodium, and I know that the molar mass is 22.990 grams per mole. Next, I ask what do I want to find? I want to find the grams of sodium. I can now set up my conversion method. In the upper left box, I place what I know, which is 5.60 moles of sodium. In the middle box, I put my conversion factor. This is where I will have the molar mass, which is 22.990 grams per mole. I want to place the molar mass so that I cancel out the moles in the equation and are left with grams. Since the molar mass is in grams per mole, I leave it as is, for in my top left box I have moles, so keeping the molar mass as written, the moles cancel out. And now, I just multiply the 5.60 by 22.990 to get 128.744 grams of sodium. Again, if you are asked to round this using significant figures, the answer will be 129 grams of sodium. Recall when this video began, a problem was given to show you what you will be learning how to solve. Now that we did a problem where you found the grams of an element from the moles, let's solve a problem for changing the moles of a compound into grams of the compound. To do this, we will use the problem mentioned at the beginning of the video. What is the grams of 0.950 moles of nitrogen dioxide, or NO2? What is the first thing I must do to start to find the answer? I need to find the molar mass. The compound is nitrogen dioxide, NO2. To begin to find the molar mass, I need to find the individual molar masses for each element. To do this, I need to know how many of each element I have and the molar masses of each element. How many nitrogen atoms do I have? The formula tells me there is only one, for there is no subscript after the N. How many oxygen atoms do I have? There is a 2 after the O, so that tells me there are 2 oxygen atoms. Next, I need to find the molar mass for each of the elements. To do this, I go to the periodic table of elements for this. Here, I look up the elements in my compound and find their molar masses. For nitrogen, I see the molar mass is 14.007 grams per mole. Ask your professor if you can use 14, or if they would like you to keep the 14.007. Many professors just use 14. In this video, I will use 14 grams per mole. For oxygen, we see a molar mass of 15.999 grams per mole. Many use 16 grams per mole, and I would ask my professor how they would like you to write the molar mass for oxygen. In this video, we will use 16 grams per mole. Now that we have each individual element's molar masses, we can find the molar mass of the compound itself. Our formula tells me I have one nitrogen atom, so I multiply the molar mass of nitrogen by 1 and get 14 grams per mole. And for oxygen, I have two atoms, so I will multiply the molar mass by 2 and get 32 grams per mole. Add these two numbers together, and you get the molar mass for your compound. This gives us the molar mass of 46 grams per mole for nitrogen dioxide. Now that we have our molar mass for the compound, we can get our grams. Recall the molar mass we just calculated for nitrogen dioxide is 46 grams per mole. This tells us that 1 mole of nitrogen dioxide weighs 46 grams. Let's think this through. If 1 mole of nitrogen dioxide weighs 46 grams, then 2 moles is 92 grams. We want to know how much does 0.950 grams weigh. To find this, multiply the 46 by 0.950. This gives us 43.7 grams. Our answer is not rounded, so, using significant figure rules, our answer is 44 grams. Now let's solve this using the conversion method. Now that we have solved this by just thinking through the problem, let's look at solving this through the conversion method. First, I need the molar mass of the compound nitrogen dioxide. We previously found this to be 46 grams per mole. Our problem states that we have 0.950 moles, so this is what we have, and we are asked to find grams. How do I do this? I create boxes to place my numbers in for my calculations. This allows me to make sure that I have the correct unit of measurement at the end of my calculation. If I do not have grams at the end, I know that my calculation was incorrect and need to start again. First, I place what I know about my compound in the upper left box. I know there are 0.95 moles of nitrogen dioxide, so that goes in the upper left box. Next, I place my molar mass found previously in the middle boxes. I place what I am looking for in the top middle box. In this problem, it is grams, so I place the grams in that box and the moles in the bottom box. Since I have moles on the top left and bottom middle, that unit cancels out, leaving me with just grams as my unit. This tells me I have it set up correctly. Next, I will take all my numbers on the top and multiply them together. Since the number on the bottom is 1, my answer will be from multiplying 46 by 0.950. This number is 43.7. When rounding using my significant figure rules, my answer is 44 grams of nitrogen dioxide. Let's recap what we learned. In this video, we looked at the stoichiometry problem of going from moles to grams. When going from moles to grams, we need the molar mass or molecular weight of the element or compound our problem involves. The molar mass tells us if I have 1 mole of this element or compound, it weighs this amount in grams. To find the grams, multiply the moles the problem gives you by the molar mass. Thank you for watching our video on problems in which you go from moles to grams. Have a great day!